I'm Drew McDaniel. I'm the program manager from the Windows Azure team, and we're going to be talking about a lot of the work we've been working on for the last year in the Windows Azure team about bringing virtual machines or infrastructure as a service to Windows Azure, and how, by the way that we've done that, we also have enabled the Penguin to sneak into the Microsoft data centers and do more Linux, run more Linux operating systems, and really open up the platform to all of the different versions that are being used out there in the industry. So as we go through this discussion with a really packed room, if you have any questions, go ahead and ask as we go through here at any point you need to. Now, as you think about the different offerings for Windows Azure and Microsoft overall, there's really that continuum, starting on the left-hand side of your on-premise, where you manage the entire stack, from the physical servers, the OS, virtualization layer, applications, all the way to the far right this is really more of a business model, which is software as a service, where in some way, shape, or form, the application is delivered to you, the service is delivered to you, and everything is managed by the provider. Now, up until the virtual machines release, Windows Azure was very much as a platform as a service. They're in on the middle there, middle right. And we managed everything from the hardware, the virtualization, the runtime, and you were able to deploy your application into Windows Azure, run that as a cloud service, and do different things. But because of that, because we managed the OS, the full stack, there's some limitations on what you could do. With the virtual machines release for Windows Azure, you're able to manage the entire thing from OS up as your component, and then Microsoft manages the virtualization layer, the servers, the networking, and that stuff in the Microsoft data centers. And so this is what we'll be focusing on today is the infrastructure as a service. Now, as for infrastructure as a service, there's a set of ways to manage it, get started. We've got a management portal and scripting interfaces. Both of those are built upon a REST API. And so as somebody programming against this, you could use either the graphical UI, we'll use a lot of that today. You could use scripting via PowerShell or a cross-platform scripting solution that's based on Node.js. And so the cross-platform one works Windows, Linux, or Mac. And then all of those are built on a common REST API. And so if you're programming the platform, if you're doing management, if you're doing large-scale operations, you go directly against the REST API to make changes, make configuration, get status of your machines. Then you come in and you start with the operating system. Now, you always have the opportunity to bring your own operating system. We'll talk a little bit about how you do that with Windows, how you do that with Linux. We also have a set of items that are available in the platform to get you started, a set of base operating systems. One thing that's worth pointing out here as we look at some of the Linux versions, at Microsoft, we knew going in, we're not the Linux experts. So we didn't go down the route of building our own version of Linux, a custom Linux. We actually partnered with folks in the industry, with Canonical, with SUSE, and a company called OpenLogic to help build the CentOS package, so that we actually get the best of the industry, the open source community, to help us do the right thing in the Windows Azure. And then we'll talk about how when you start deploying it, one of the key differentiations that you have between what's in Windows Azure today and what we have with infrastructure as a service is this notion of a persistent disk that's backed in cloud storage. Now, we back everything in our Windows Azure cloud storage as compared to building a new solution for block storage. And what this allows is a lot of flexibility in how you manage, how you move things in and out, and it makes it a lot more open platform as compared to what you may have in some of the competitors. And this just talks about what we have. We'll look at what we have in the platform now, both on the Microsoft side and on the open source side. The open source side tends to be increasing as we go. So, for example, we've got CentOS 6.3 in there right now. As Red Hat's released 6.4, we'll be moving that over as a CentOS 6.4 version. In addition, down in the coming soon, right now Windows Azure, the virtual machines, is in a preview state. And so as preview, we don't have the full production SLA, and our recommendation is that customers aren't running production workloads while in preview. As we move into general availability, we remove the preview tag. The full SLA, full support will be behind the Windows Azure virtual machines. In addition to that, we'll bring a set of pay-per-hour instances, SQL Server, Standard Enterprise, and Web, as well as BizTalk Server, Standard Enterprise, will be in the platform to run production workloads on there depending on what you want to do. And we'll also talk about how you can bring the software, that software or other software, to Windows Azure to run that there. So with that, the best ways to really get into this is to just look at a few examples. So let's flip over to the demo. All right, so what we've got here is this is the main portal for Windows Azure. As you come into here, I've got a set of things set up already on here. This is actually one that I use for my normal work environment. We're going to look at the virtual machines. And if you come in here the first time, you wouldn't have existing machines in here. It'd be a little arrow that says click here to start creating a virtual machine. We click a little new arrow. First thing you're going to notice is that there's two options for creating a virtual machine. There's a quick create, which will go through and just take a lot of default answers to the questions. You can quickly get a virtual machine up. But for the first time going through this, I normally suggest people look at the gallery version. The gallery goes through a little more step-by-step process, shows you a little bit more of the functionality and flexibility that the platform has. And so that's what I'd like to do today. So as you see in here, here's the list of images that we talked about earlier, both Windows, Microsoft software, and various open source software. For some of these, like for example Ubuntu, we've got the long-term support version, the 12.04, and then this version here will be the one that's always recently released. So right now we have 12.10. They're working on 13.04. That will come in here to replace this recently released one fairly soon. For this, we'll go through and just click off and do a 12.04 deployment. You come in here and you answer a set of information. So you're going to give the host name for the machine. So we'll just call this Ubuntu 2. So we got one out there. Give it a username. You also have the option, if you'd rather do SSH for authentication, you can upload an SSH key and use that for authentication instead of username and password, or you can do both. And now when you come to this page, you have the option of what we call a standalone virtual machine or connecting to an existing virtual machine. So when you're looking at this, it's good to know essentially the way that Windows Azure configures itself is machines are deployed into a container that's called a cloud service. You can think of this container as a box for virtual machines. At the top of that container, you have what we call a virtual IP address, or VIP, which is the internet-facing IP address. The machines inside that box have a data center IP address that they can use to talk to each other. And so you essentially have full connectivity in the machines in the box, but then you can control what connectivity comes in through that virtual IP address into those virtual machines. For this, we're going to go ahead and put it into a machine associated with a machine that's already existed. I've created an Ubuntu 1 earlier. And so this puts this new machine in that same box as Ubuntu 1. And I'll show you some of the advantages of that. You can select the location. In this case, because Ubuntu 1 is already deployed, it's deployed in the US West data center, so that's fixed. If we were deploying just in general, we would have a set of regions. Now, Windows Azure builds out the data centers always in pairs. And so there's 2 data centers in North America, there's 2 data centers in Europe, 2 data centers in Asia. This is partly because of the way that our storage works. We do storage replication between the data centers. We'll talk about that as we drill into that. But you select which data center you want to place your virtual machine into. Uh-oh. Let's hope this comes back. All right, 1 second here. I was not expecting to lose internet. Brilliant. What's that? You know, in a cloud, it is, I used to have to lug machines when I used to do on-premise distributed systems, and I'm like, I love the cloud. I just connect in until this happens. All right, well, let's give this a moment. We'll see if we'll come back into this. What's that? Excellent, excellent. Go ahead. There we go. That's a great question. The question is, I thought there was or was going to be a north and south data center for Windows Azure. The answer is yes. We actually, the north and south, north central and south central data centers were actually the first data centers that we had for Windows Azure in North America. When we moved to the virtual machines, one of the things that we found is that we needed to look about how the data center network was set up. And essentially, the previous data center network, but going from compute to storage, would essentially go up to our edge and back down. And with virtual machines, where everything is running across that on storage, on persistent drive, that network architecture didn't work. So we've been going through, and all of our new data centers have been built out with a new network architecture that has a spine that has extremely high connectivity between storage and compute. Some of these existing data centers, and specifically North Central and South Central, are actually being built out being rebuilt to have this new spine architecture, so we'll be able to do virtual machines there.
So is it that the older stuff that was there is still there and you're adding on, or did those get shut down and everything?
Yeah, the question is, was the older stuff, is it still there, or is it being shut down and replaced? The older stuff where we run our platform as a service, it is still there. The way that it's happened is if you signed up for Windows Azure, it's like May 2012 or some time frame, you actually got those data centers. We were actually, in those physical plants, we were running out of capacity and physical space. And so those have been closed off for new subscriptions. New subscriptions get east and west. Over time, we may open those back up, but we've actually, the appetite for Windows Azure and some of the cloud services was probably a little more than was initially expected. So they didn't buy quite enough land and data centers. In the east and west, and everywhere we have now in the 6 that are out there, we have a large amount of capacity to purchase and continue to extend. But those data centers, as people have been moved, they are being retrofitted. We're debating on if we open those up in general, or we keep them in the future, or are they more for specific purposes? Like sometimes we run conferences and we run all the labs on the virtual machines, and that may be thousands and thousands of cores. Sometimes we reserve those into specific data centers. So thank you. All right, let's go back to my demo box, and we'll see if the internet works for us. Okay, so we're back in here. We'll go ahead and connect it to the virtual machine, Ubuntu One. We're going to place it into, you create a storage account. So Windows Azure Storage has this notion of storage accounts. You select which storage account you want to put it into, or you can let the portal create one for you automatically. I'm going to put it in this demo just so that so we can show you a little bit more information about it. And then there's this notion of an availability set. A little bit later in the talk, we'll talk exactly what that is. But at a high level, you think of the availability set is this informs Windows Azure that a set of machines are a tier of an application. So for example, if those machines are both web front ends, this tells Windows Azure these are the same machines. Spread them out across the physical hardware so that there's no single point of failure. If you need to patch the underlying host operating system, don't take these machines down at the same time. And so it's information to Windows Azure on how to treat those machines such that they get spread appropriately and handled appropriately for host patching. So for demo purpose, I'll put these into the same front-end availability set. Click this off and let that go ahead and start creating. Now, this is the platform images. These are the images that we've worked very closely with various providers in building these. We have test teams in Windows Azure and those partners that are testing those images. But there's a large amount of stuff, especially in the open source space, where it may not have as much testing. There's just a huge variety of images. And for that, we have this notion of what we call VM Depot. Now, VM Depot is something, I'll actually go to the web page here. You can actually access it either through the portal here or through the website. VM Depot is something that we've done. Microsoft OpenTech, which is a Microsoft subsidiary, has built this site for community members to upload images to that site of open source images that are designed to run in Windows Azure. They can be downloaded and used on-premise, but really the focus is, and the hook in is to put these up here so they can be used on Windows Azure. And so this site, you could come in here, and you could do a search. Say we do a search for WordPress, and we'll find a set of images that have been uploaded both by individuals You see the publisher name, and you can see what that person has published. If you click on this person's the link here, you'd find out the ratings and reviews of those images, as well as some more well-known publishers. Bitnami is a publisher that does a lot of these packages for multiple cloud platforms. And so you could download them from here, kick these off into Windows Azure, or what's even a little bit easier from the portal, you can browse that same site. Now, in here, you don't have that same search functionality, but it's the same set of images that are available. And so for this case, I'm going to go ahead and grab the WordPress for Ubuntu. We'll click this one at 1210. Download this to the same storage account. And what this is going to do is it's going to initiate a copy of that image over to your storage account. The storage account that they use are in Microsoft data centers, and so it's fairly quick as downloading it into your storage account. And so we'll let that run as we go through. All right, now, as I mentioned before, the machines go into the box, this cloud service container, and we'll talk about how that's connected into the cloud service. But then to connect into the machines, you connect into this virtual IP address. Now, in this case, we've put 2 Linux machines into the same cloud service. It has one internet-facing IP address, and so when you want to connect into it, we go into the dashboard, and we show you the details for connections. So this is the DNS name that I had given that container, that cloud service, when I first created it. And then this is an IP address. This is the port where you connect to for SSH for this specific machine. And in fact, if we go and look at our list of endpoints, you can think of the endpoints as the security. This is what you're allowing through from the internet into the virtual machine. You see the same port number that's being mapped from the public port over to port 22, the SSH port on that virtual machine. If you were running this and you wanted to have no internet connectivity to that machine for management purposes, you could remove that port and then there's nothing coming in. In addition to that, you can use firewall rules to further limit who is able to connect into that machine. But so with this, we'd actually just, if we were to grab the DNS name, actually I'll just grab this whole thing. Connect into this. And we'll connect into our virtual machine. Now, one thing I'd like to point out, let me flip over to here to show. You'll notice that we are showing in the portal an SSH certificate thumbprint. So when you've deployed this machine, it's up there in the cloud. We give you the DNS name to that machine, but there's no guarantee that when you open the DNS that you're really absolutely hitting that machine. And so what we do is when we deploy the virtual machine, we grab the SSH, the cert that's being used on the server side to identify that server. We show that into the portal, and then when you come up here, you will see the same thumbprint, and this allows you to verify that the server that you're actually connecting to and the certificate that will be used to secure the traffic is the same cert, is the server that you had meant to connect to. And so by this, then you can say, I trust it, and you'd log in using the login name that you'd given and the password. If I type the password correctly. And we'd be in. So this is just the quick how to get connected, how to get the machine up and running. And we will return back to the slides and then continue on. Okay, I threw in a slide here. It often comes up, especially on the Windows side, a little less on the Linux side, but I went ahead and put this in here. Licensing. So with licensing and open source software, you're not really licensing the software. You're typically paying for a support contract. So the first thing you want to do is you want to have a conversation with your vendor on the support. If you've purchased a support contract for a piece of software or an OS specifically, does that transfer to Windows Azure? Some do, some do not. Of course, the ones we're working with very closely tend to have a support contract that transfers. In addition, we're working with these guys to have an integrated support contract that you'd be able to purchase as part of your Windows Azure subscription for running open source. For running Windows Server is charged on a per-hour basis. If you have on-premise, you can bring up your VHD, but the Windows Server license doesn't transfer. The license for Windows Server is always paid for as part of running Windows Server in the cloud. Applications, on the other hand, specifically Microsoft applications, can be licensed in one of two ways. One way is what we call license mobility, which is something that's granted if you purchase your application and you have software assurance. That allows you to move it to a cloud provider from on-premise. In addition, like I said, we will have initially a couple sets of per-hour licenses, one for SQL Server, one for BizTalk, that allow you to just buy the license on a per-hour basis and run that machine in the cloud. And then finally, for external application, third-party application, you want to talk to your vendor to understand what their restrictions are or licensing models are around the cloud. Because some things are a little bit different in cloud. Like, for example, on Microsoft, you're required to have the software assurance to run the software in the cloud in a fully licensed manner. So we're going to dig into a little bit of disks and images and how we actually use the back-end storage of Windows Azure. First slide is really about terminology. So both disks and images, as we'll see in the portal, these are both VHD-backed items. The difference is that an image is something that is prepared and ready for deploying out as the OS for a machine. An image is always generalized, so in the Linux side, there's an expectation of no passwords being configured. On the Windows side, the images are always sysprepped and generalized, and that allows us to set the host name, set the configuration for that image as part of the portal. The images both are user images that you can upload or download from somewhere like VM Depot, or the images in the platform. Disks, on the other hand, are either disks with an OS or disks that are just data disk. When you provide a disk with an OS, we just attach that to a virtual machine, spin that up, and the expectation is it's already been configured, it's got a host name, it's got all the configuration in that disk already. And of course, a data disk is as you'd expect, just a plain data disk. And as we go through, we'll dig in and I'll show you a little bit of the different examples of disks and images and how those interplay. Now, I think it's useful to walk through a detail of what's happening under the covers in Windows Azure when we provisioned a virtual machine, what was actually happening. So the first thing is when the user comes in, says, I want a new virtual machine, provides a set of information. Host name, password, SSH keys. On the Windows side, you can have it join a domain, configure automatic update. That gets packaged in and sent into Windows Azure in our management layer, and that's converted into an ISO image. The ISO image is then copied out to a location so that the data center can access that ISO image when it needs to. We go in, and in this case, if we actually have done things through the platform gallery, we take a copy. So the platform gallery, you have the images, and images are always copied to make the VHD for the OS disk. Now, it's worth pointing out here in Linux, there's always a Windows Azure agent that's attached and installed in the Linux image. And this is the one thing you're going to need to do if you bring your own Linux image up, is install this agent. What the agent does is it's really designed to make Linux work well in the Windows Azure data centers that, for all honesty, was originally designed for some of the ways that Windows works. So I'll talk about in the next slide exactly what that agent does, but it's a key thing to remember when working with Linux. The disks, the VHD files, are in your customer storage, and so you have access to them. But before we put them onto a virtual machine, we take what's called a lease. This is effectively a lock on those. And this prevents somebody from writing to the disk while the Windows Azure hypervisor is trying to access that. You could still read from the disk, and I'll show you a little bit how you can actually do snapshots and things like that. But if you tried to write to the disk or delete the disk in your storage account, you'd get an error message because it's being used. So then in the data center, we're going to select a physical machine. We'll create a VM guest container based on the size parameter. So if you specified large, medium, small VM, we'll create that size, give the right amount of RAM. We create a cache VHD. So there is a VHD that is local to the physical node. This is very important to notice because if you use that for your data and that data you're expecting to be persistent, if there's a failure of the physical node and it needs to be moved, you would lose that data. So that you need to think of the cache VHD as ephemeral data. It can be used as swap file. On Windows, we use it for paging space. Databases use it for like TempDB. But you don't want to put your customer data on there. We had one customer that inadvertently put all their customer orders on that. It was a small company. Service healed the machine because of a physical failure, and all that data was lost. And it was very, very unfortunate. So you just want to be very careful to not put it on this cache VHD. So the cache VHD is surfaced up into the VM, mounted in the VM. We also mount the OS disk and any data disks that have been attached. And then the ISO is copied over. The agent then, when it boots up, looks at the ISO, grabs the provisioning information off of the ISO, configures the virtual machine as the customer had specified, and then removes the ISO. And at this point, the virtual machine is the customer's to use. You can SSH into it, configure it, run it as however you want. Okay, so this I want to go through. This talks just a little bit of detail of why that agent is needed, what the agent's doing in Windows Azure. So one thing the agent's doing is getting the SSH key. The VM needs to talk to the service management interface to get the keys on the machine. So it does that, brings us down. The other thing it needs to do is if the name changes. So as I said, the Windows Azure Data Center was designed for Windows. In Windows, if you change the host name, it reboots and will do a DHCP request. When the DHCP request goes through, our internal DNS server picks up the new name of the host, and everything is happy. Linux doesn't have that same requirement, so the agent sits there, and if the host name changes, it just does a basic update to the IDNS server so that the infrastructure has the current host name of the machine. And then finally, if the underlying hypervisor had a hardware failure, something happened to the physical node, we are going to stand it up on the virtual machine on another node. The agent goes through and connects resolves any issues with the internet connections, the Ethernet connections, because it's a separate physical node. It has a separate MAC address. We want to make sure that all of the links and symbolic links to the internet or the IP addresses, the NICs, are appropriate. And so that's what the agent is doing. So the Windows Azure storage, the way that it operates is when you connect either your OS disk or the data disk, it is then placed on 3 independent physical drives. So every bit of data that you write on your persistent drive is placed on 3 separate drives. This is done, now this is completely transparent to the virtual machine, but in this manner, if there is a failure of one physical drive, Windows Azure Storage will pick this up, detect that failure, and automatically recover that on another disk. In addition, by default, Windows Azure Storage has geo-replication. And so we always, as I said, we build out our data centers in pairs. One of the reasons for this is that the storage in each of those data centers is replicating with each other. So when you go in and you create a storage account, by default, it sets it up as geo-replicated. And it will asynchronously replicate all of the content to the other data center. That way, if there was a catastrophic failure, the data center was lost, all the compute was lost in that location, we'd be able to spin you up and you'd have the storage already available in the alternate data center. So this gives you not only 3 copies, but you end up with effectively 6 copies of your data for extremely highly reliable storage. If you choose not to have the geo-replicated, you can say locally redundant, and so you'd have 3 copies of your data, and that gives you about a 30% savings on the overall cost for the storage. And then what about the virtual machine? So the disks are persistent. They're being replicated in Windows Azure Storage. If the machine itself fails, Windows Azure will detect this. We're continually monitoring the underlying physical machines. If any machine stops heart beating or detects an imminent failure using like SMART or detects issues with the network card, it will take that machine down, will bring up a new physical host, and then connect those persistent disks, the OS disk, the data disk, back to Windows Azure Storage, and you'd be a way to go. In that scenario, again, that hardware failure, the only thing that would be lost here is it would be a reboot, and that cache drive would be reset back to an empty cache drive. So with Windows Azure, we've built the hypervisor, the data center out using Hyper-V. We had started off, it was Hyper-V based on 2008, about 3-4 years ago. At this point, the hypervisor is a derivative of 2012, and so you have the functionality that you have in the hypervisor, the use of the VHD format, it's the exact same VHD format that you use on-premise. So if you wanted to move a machine from on-premise, virtualized, up to the cloud, it's as simple as uploading the VHD files. There's no conversion process you need to go through. With Windows Azure Storage, you can just easily upload it in there. And the same thing goes, if at some point in time you need to download, you're done with the machine in the cloud, you want to bring it back on-premise, you can easily download the machine and run it on-premise. It's just the same VHD format, just works with the same integration components as Hyper-V, so it's very seamless in being able to move things to and from the cloud. In addition to that, if any other cloud providers that are working on Hyper-V, you have that same functionality. And so there's a lot of hosters that are basing their platform on Hyper-V, and you have that exact same flexibility of moving them to and from different hosters. Part of this is, we think Windows Azure is a great place to run your machines, but you don't want to have lock-in. If you need to leave for some reason, you need to bring it on-premise, you have that full flexibility. It also allows it to make it very easy for a disaster recovery site, so you can be uploading your data into the cloud. We don't have it in place right now, but we're working with the Hyper-V replica team to push up the data through Hyper-V replication, and you just have your Windows Azure as kind of your DR site for your on-premise. Now, the disks in Windows Azure in Windows Azure Storage are a huge number of disks. And these are spread out, and we have a large number of customers on here, but we wanted to just walk through some of this, how this operates. So you've got also disks on the host. So the host OS, you've got your temporary storage, and then your persistent drives are into Windows Azure Storage. Now, what I want to represent here is that the physical spindle that parts of the drive of your disks are on may be shared with other customers. And what Windows Azure Storage is doing is it's constantly monitoring the access pattern to each extent on these disks. If it finds that an access pattern is higher than expected, or there's two customers hitting that disk at the same time at a fairly high level, it's going to take one of those sections, move it to another physical spindle, and remap it. Now, this is really important to know when you're thinking about when you're planning your application, designing it, and especially if you're doing a performance test, is you want to let the system warm up, let the disks warm up at about 45 minutes. Because in the same system, if it finds that you're getting hit very hard, you're hitting the disk hard doing a performance test, it's going to split it and put it to different spindles. And so it does that a maximum of 4 times. And so about 45 minutes time frame is what you want to do to let things warm up, to do a perf validation, to really see what the performance you're going to get at steady state. Now the disks then, the OS disk is a little bit different than the data disk. The OS disk has a maximum of 127 gigs. Windows, we default to 127. The Linux disks are defaulted to 30 gigs in size. You can change that. You can extend the Linux out if you wanted. You could extend the Windows down, shrink the Windows down if you wanted. But a key point is those disks are optimized for boot performance. They have read-write caching enabled on them. The write caching is write through, but it will cache it locally, and so they're really designed for booting up efficiently. The data disks, on the other hand, are really designed for higher performance and higher scale. Each data disk is up to 1 terabyte in size, and you can have a varying number of data disks based on the virtual machine size. So on the extra large machine, we have 16 data disks, giving you 16 terabytes of storage available. And it goes down in halves as you reduce in size. So the large size has 8 data disks, up to 8 data disks, and down to the small and extra small, each are allowed 1 data disk. The data disk is really what you want to use to maximize performance. So if you're putting your SQL database, if you're putting Active Directory, domain controller database, if you're running MySQL, any of that, you really want to run on the data drive for performance. If you put it on the OS drive, the performance you're going to get out of that is not as good as you'd like. The OS drive is also surfaced as a SATA drive as compared to the data drives being surfaced as SCSI, and so you'll just get better performance on the data drives. In addition, in the data drives, you can configure the caching. By default, our caching on the data drives are no caching. This sends all writes off to storage. As you're doing a large number of writes, or reads for that matter, the back-end storage is going to give you better performance because it has many more spindles than any of the caching that's available on the local disk. However, if you're doing something small, and it stays within the cache size, if it needs to stay within about 10 gigs in size across all disks, then the local cache will give you some performance, especially if you're doing single disk type operations. The key is, though, is if you're doing that, if you do use read caching on the data disk, you want to make sure to run your workload at scale as you expect, because when you start having cache misses, the impact on the cache miss will be fairly heavy. And so you want to make sure that the performance is consistent, and typically the recommendation is to use data drives for this. Cost of the machine, of the disks, so you pay both on transactions, so I/O, a million I/O for about 10 cents. Storage, this is based on the current numbers, but looking at if you're doing 100 gigs of storage, it's about $7.50 a month. The way that we structure our storage is the price decreases as you use more of it. So the first gigabyte's a price, then it's down to the next 50 gigabytes, and so it reduces as you go and you use more storage. And the usage is you pay for what you use. And so if you have let's say you have a data disk that you've provisioned out as 300 gigs, and you start writing into it, but you only write 150 gigs, you're only paying for 150 gigs. You're not paying for 300. So it's pretty easy. If you're not sure how much storage you're going to need, you can provision out a terabyte of storage as your data drive, but you're not going to be charged for that. The one thing to note, though, is as you write into this, those are getting committed into Windows Azure storage. If you were to come in the OS side and delete files, let's say you wrote up to 150 gigs, and then you delete it down to 40 gigs, the delete happened in the OS, not in the storage subsystem, and so the storage subsystem still has the high watermark and is storing the data at the 150 mark. So if you write a whole bunch, then delete it, and you keep it deleted for a long period of time, you may want to look at doing a copy to a new disk so that you're only paying for what you're currently using. We are investigating, we are investing in solutions that will detect this from the host, push that up to storage, let it know that the data's been deleted, and free that space back up. But as of right now, you pay for what you use, but once you use it, you continue to pay for it. Okay, so let's flip back over. And look at some more of the details digging into the disk. So first thing we're going to do is we're going to come over here and let's see if the download of the image from VM Depot completed. So at this point, the image was downloaded, and it's ready to be registered. What the registration is so there's really a two-step process here with our data disks or, for that matter, OS disks or images. There's the VHD that's in Azure storage, and then there's a registration for the image or disk in Windows Azure in the management system. And so at this point, it's in Windows Azure storage, but we don't have it registered with the system. So here we're going to go through and we're going to register this. We give it a name. I'm going to do WordPress from VM Depot. So we're going to need dashes. And then this is the URL where it is in storage. So that's going to register, and we'll flip over here. So this is a third-party tool called Cloud Explorer. Let me do a refresh. And so here is the image that we just registered. And in addition, here are the VMs that are running. And if we look at these, you can see that they are being written to. So these are the OS disks. Let me refresh, and you'll see that better. They should be written to. Let's look at our machines and make sure they are running. Yeah. But these are the OS disks for those two virtual machines we've deployed and the image. And so if we come in here, and what I want to show, as I mentioned before, the image is you're going to copy the disk. And so if we come in, and now if we come into our gallery, we see we've got the original platform images, but then you also have this My Image. So this is the image that we downloaded from VM Depot, and we can use this to create a virtual machine. service. Here's where you select your size of the different VMs that you want. As you'll note here, from small, medium, large, they just double. So you go from 1 core, 175, 2 core, 3.5, up to 8 cores and 14 gig of RAM. So I don't run out of cores in this account. I think I'll stay with the small for the demo purposes. And again, select where you want. Now, in this case, you'll notice that there's a reduced set of locations. This is because the image now exists in the US West data center. We're going to need to make a copy of it. In Windows Azure storage, if you make a copy, it is effectively a shadow copy operation, so it's almost instantaneous. We wouldn't want to take this disk and now copy it over to Europe. And so it forces you to select a location in US West. And I'll go ahead and also put this on that same set of cloud service just for demonstration purposes. And I'll throw this in the availability set as well. And so at this point, it's going to go and do the same operation as it did from the platform image, but instead of copying something out of these platform image accounts, it's going to use that data disk, or sorry, the image that was loaded in here. Now, as that's going on, so as I mentioned, we use the capability of Windows Azure Storage, the fact that a copy is really fast. It's also something that you could use. And so what I've created here is this snapshot folder. And I've got these VMs that are running. At any point in time, if I want to come in here, and let's say I want to snapshot that current state of that VM, I can come in here and do a straight copy operation, come over to here, paste that in, and I've got an immediate snapshot of that machine. I'm going to rename it. And so now this VHD is not generalized. It's not something you would want to use as an image, but you could certainly use it as a disk. And so if I were to come into the portal and move over to the Disks tab, here I see the disks and data disks that are used for the VMs that are running. One that I had uploaded before for a SharePoint test I was doing previously. But now I want to add, this is essentially registering that data disk, or sorry, the OS disk. So this is the DRIM snap. And then I can browse to that location. Should be able to browse to that location. There are no blobs. All right, let me do a refresh on the portal and see if this blob shows up. It should be showing up there. All right, let's register this guy. All right, I'm not sure what's happening there. I'll have to look at that. Okay, well, we'll skip over that for a moment. I'll come back here in a moment. All right, and then, so here, as we've seen, as that machine that we just provisioned has deployed out, it's made a copy. So this was an immediate copy of the previous machine, of the previous image, and now this is being written to, this is the OS drive now for that DRIM-WP machine that we just provisioned out. So it just made that quick copy. It always makes a copy, and it shows up in the same container as your original machine. In addition to this, as I mentioned before, these guys, we did a copy operation, but if you were to try and do a delete operation or write operation, you're going to get this error message. It mentions something about the lease not being specified, and this is that lock that we take on the disk so they can't be modified or written to by a user. But as you can see, the read operation was easy to do. Okay. All right. Okay, so we've talked about base virtual machines, storage. The other big part of the virtual machines release and the infrastructure service is both our networking and high availability. So the networking, as we talked about, coming through the internet side, you can use TCP or UDP traffic coming through that endpoint. Between the machines within that cloud service, you have full IP-based connectivity. So TCP, UDP, ICMP, anything you want there, you have full ports open, full connectivity to those machines within that cloud service. You have port forwarding, so you can select, as we showed with the SSH, a specific public port forwarding out to a unique port on the private machine. And so that's how we do SSH, multiple machines. Same thing goes on the Windows side, RDP. Every time you deploy a virtual machine, you get a different public port pointing into 3389 on the Windows machine. And then finally, if you're doing load balancing, you can, and we'll show this in a minute, you can do custom load balancer probes configuration so that if your machine is not fully healthy, the machine cannot respond to the probe, or of course if the machine is down, it won't respond to the probe, and the load balancer will spread the traffic as expected. Now the availability sets, this is what we talked about before. You definitely want to put machines that are doing the same operation in an availability set. It is desirable if you have, for high availability, if you deploy 2 instances and you put them into an availability set, we'll spread them out. As we're showing here, they'll be spread across different racks in the data center and different physical nodes. You can then use the load balancer to then load balance traffic across the machines. And if for some reason one machine were to fail, the load balancer will immediately stop sending traffic to that machine. And Windows Azure, when it detects that machine's failed, it will bring that up on another physical device. In addition, we want to talk a little bit about networking. So networking, the machines we've deployed them just to a straight cloud service, and we're using what's called internal DNS. So Windows Azure provides an internal DNS service to allow you to connect to the machines in your cloud service by host name. You also have the opportunity when you use virtualized networking, and we'll look at this in a moment, to bring your own DNS. So you can specify the DNS server for all of your machines in the virtual network. That DNS server could be an Azure VM, or it could be an on-premise VM. Because with the virtualized networking, it allows you to create a site-to-site connection, a site-to-site tunnel, VPN, from Windows Azure to your on-premise location. So we're going to look at, this is the virtual network. And so what we've set up here in the virtual network is a set of subnets in Windows Azure, and then we've defined a site-to-site connectivity from Windows Azure to on-premise. So this is a VPN tunnel. It does go over the internet, so you have latency. So you want to think about the applications that you deploy there. So if for example, SharePoint, putting the database on-premise and the machines in the cloud is not going to be a great thing for SharePoint because it doesn't deal with high latency between database and the application layer. Other applications work fine. I mean, the best way to think about Windows Azure and your site-to-site VPN connection is it's like a data center, a branch office data center. So the things you deal with in a branch office scenario of latency is very similar to what you'd be looking at here with Windows Azure. And what this does is it allows you to give that really nice hybrid scenarios where you can put parts of your application in the cloud, parts on-premise. For example, at Microsoft, a lot of our test teams have moved to using Windows Azure for their test systems, but our reporting systems set back in on-premise. And so the reporting systems are on-premise, all the tests are being done in Azure, and it's just reporting the results back to the on-premise machine for reporting purposes. So let's look at this. All right, so now that we've got our machines deployed out, I had mentioned, so these machines, look at these instances, if we sort by DNS name, a set of them have been in the same cloud service, so they have the same DNS name. If we go over to our cloud service, you'll see the connection. Here's our Drone Linux for the talk. And if I drill into this, you get some information. Here we're going to show all of the endpoints that have been created, the total number of cores that are being used for this service, some statistics about the service. If I look at the individual instances, this is where I want to point out. So we've now got what we call default domains and update domains. Now, default domains is a logical construct, which is these are separated into independent single points of failure. So in Windows Azure, everything above the rack is totally redundant. But what this means is that these machines are guaranteed to be on separate racks, so that if you have a top-of-rack switch failure, for example, that it wouldn't take down all the machines. Now, the machines tend to be spread across multiple racks, so even though this is 0 and 0, there's no guarantee that these are on the same physical rack, and in fact, in most cases, they're not. But we also don't have the guarantee that they are spread to multiples. On the other hand, update domain is what we use for when we're going to service the host operating system. So update domain is we spread these machines out, and we give you 5 update domains for virtual machines. And so if we added a 4th machine, it'd be an update domain 3, 5th one go to 4, and then if we add a 6th machine, it'd go back and it'd be an update domain 0. The way that these are used is that when Windows Azure needs to patch the underlying physical hypervisor, it will take down machines in update domain 0 first, patch the hypervisor, bring those machines back up, wait for at least 10 minutes, and then proceed to the next update domain, and go through that until it's processed all the machines in the data center. It does this so that you don't take all the machines down at one time, and also that 10 minutes is so that if there's any kind of a stateful application, it can do its replication and sync between the machines once it's come back up. On the other hand, if you don't put machines into a update domain, you just say it's a single instance VM, those we try and put together into one pool so that we can get those done as rapidly as possible. And in the preview, we don't have the notification mechanism. As we go to GA, there'll be a notification mechanism that will say, here's when we're going to update your single instances. We're going to purposely make those in kind of off business hours and update those all at once in an off business hour manner for those applications, for those VMs that you don't have high availability. For the ones you have high availability, we will make sure to honor that high availability. So let's look at one of these machines. And so if we go into Ubuntu 1, I will show you that. So we created a little bit earlier an HTTP endpoint, so public port of 80 and mapping to the private port. If I wanted to then load balance that across the different machines, I can come into Ubuntu 2. I'm going to add an endpoint. So here I could do whatever endpoint I wanted, but as a load balanced one, I can select this HTTP port 80 because it's already created on one of the machines in the cloud service. I give it a name. Here, I'm going to call it the same one. And here, again, I'm going to put it for the machine, port 80. And so this is going to provision that endpoint out, and traffic will be split between those two machines as it comes in. If one of those machines were to stop responding, have a hardware failure, the load balancer would then redirect all the traffic to the remaining machine. Okay. So we talked a little. Now these machines are all set up outside of a virtual network. I want to look at a little bit what it looks like to build out that virtual network and then how that changes the deployment of your machines. So in a virtual network, I don't have anything created yet. I'm going to go ahead and create a virtual network. There's a little wizard that's going to take you through here. Demo VNet. You create it into an availability group. Now, what an availability group is it tells Windows Azure, put these things together. So in the previous world of PAS, you would say, hey, I want this compute and storage to be close together. With virtual network, we use the affinity group to say, put all of these machines close together because we want to have connections, very low latency connections between those virtual machines because they may be running a common workload. So we selected the affinity group. Next. And now we map out the address space. So the top part is, this is the total address space we're going to map out. You can map out, in Class A private, B or C private subnets. Then within there, you carve out your address space. And so let's say we're going to do a front-end network subnet. Let's say we place this at 10.1. Let's say we want 256. So here you can do by address count, or you can do the normal CIDR, the /24 network. You create your subnets, and so these are subnets that are going to be defined in Windows Azure. So this is, let's say, a backend subnet. Let's say we use those. You can specify a DNS server. I've pre-configured a couple DNS servers already. Again, that DNS server could be in Azure. If you leave it as just blank, specify DNS server, then it continues to use the IDNS service. Depending on what you're doing, if you're doing an Active Directory, the IDNS service is not going to be able to support all of the records for Active Directory, so you tend to stand up a VM as a DNS DC for Active Directory. This is also where you can configure an on-premise connection. So this will allow us to go through and configure the gateway. So this is the gateway machine that stands up in Windows Azure. So let's say that would be at say 10.3.0. Oops. And then you can specify the local network. Now, specifying the local network, this is where you would model the address space that is going to be provided by on-premise machines. You give a name to it. This is the IP address of the VPN device. So you'd have a VPN device that's setting on the internet, and then you can model the address spaces that's going to be behind that VPN device. I don't have a VPN device set up, so I can't configure this right now, but this is the wizard as you would use to get that on-premise connectivity. Let that run through. And once we create the virtual network, then we'll have an additional option as we deploy virtual machines. So let me just create, just take a moment. All right. And now when we create a virtual machine, one point that it's worth mentioning is the passwords. Because these machines are on the internet, both for Linux or Windows, make sure you use very strong passwords. You don't want to use easy-to-guess passwords. We had some customers use some fairly easy-to-guess passwords that ran into some problems in brute force password attacks. So we'll create this. Now, in this case, we're going to create a new cloud application. So this will be Drim. I'll just do VNet, new hosted service. I'm going to go ahead and put it in that same account. And now, in our locations, we also have the option of what's called the virtual network. So now if I select this virtual network, I now have the further option to select what subnet I want the machine to be in. So if I put in the front-end subnet, I'll go through. And one of the big advantages is with a virtual network, inherently when you put the machines in the same cloud service, they have full connectivity and full IP-based connectivity. If you put a machine in separate cloud services, but both cloud services are part of the virtual network, they also have full connectivity, full IP connectivity. So it's the same as being in the common cloud service. So a typical design point is creating a virtual network, and then for each tier of the application, putting it in its own cloud service. That'll give you an endpoint for load balancing. You can do availability groups, but then connect those cloud services together as part with that virtual network, and so that they all can talk to each other on that data center side of the network. Okay. Now, one other thing I'd like to point out. So we've talked about creating machines and virtual networks, disks. We've looked at images. There's also some third parties building solutions around Windows Azure that makes it easier to build out systems. So one of those is SUSE Studio, which is they allow you to build out a custom appliance, and then you can push that into multiple clouds. And so if we were to come in here, let's go ahead and create a new appliance for Azure. You can select SUSE or OpenSUSE. We'll create a server. For Azure, you want to select a 64-bit operating system. 2. And then in the creation of appliance, you're able to come in and select the different packages of software that you want installed. Let's say you want to throw on, let's see, Apache's not here, so you can add the package that you want. Go through and you can do different configurations, startup scripts that you want the machine to run. You get through here and you're going to be able to build this. You say, I want to build it for an Azure image. This tells the SUSE to package in that guest agent to make sure all of the drivers are correct for Windows Azure. Click off and do build. And that will generate this appliance in a form that is designed for use on Windows Azure. You can come back and change the build, change the configuration later. Once that's done, let me go up here and just show you one that I've already got. Once you've built your appliance, it's stored now on the SUSE side. We haven't uploaded it anywhere, done anything with it. So you can come into the machine, and now I can upload it if I want. I'm going to upload it into Windows Azure. I'd already uploaded it once. Here, let me kill this. All right, well, once that's deleted, so what's going to happen is you upload that. It's going to copy it over to Windows Azure, register it as an image. And so this is, again, very similar to what you're doing from VM Depot. You're building out the image as you want, configuring it, moving it to Azure, and then you can run it from your accounts. You have the option to select. Actually, do I know? Let's see if I can upload this one. Yeah, maybe not right now. You can select that as an image, create multiple machines off of that image. All right. So in summary, I want to walk through just some of the differences, similarities between Windows and Linux. By and large, with what we've done with virtual machines, virtual networks, it is fully supported for Windows or Linux. You can mix and match as you want. So we've got gallery images for both of them. You can bring your own image for either Windows or Linux. If you bring your own Linux image, what you do want to do is make sure to install the agent that is available for open source. Virtual networking is supported. Configuration of hostname, username. Password is optional if you're using SSH on Linux. We don't do SSH on Windows, so that's one thing we don't have on Windows. And then Windows has a few more configuration things that we do through Windows Setup, joining a domain, configuring WinRM for remote PowerShell, and then the SSL certificates we can do on Windows. It's not quite there yet on Windows, and this is for SSL on the Linux machine, although there's some ways to work around that. So with that, I'll open up if there's any questions. We've got some additional resources. This is the endorsed distributions. This site shows all of the distributions that are there, as well as the configuration that is expected for the distributions. If there's any patches that are needed for that Linux, a set of guides, and then, of course, the Windows Azure agent. If you're building your own, you'd want to grab the agent from GitHub to install onto your VM. And, of course, please fill out any surveys, the surveys at the end to give us feedback on the presentation.